A solenoid actuator, or simply a solenoid, is typically used for on-off control of a valve. Solenoids can position a valve from fully open to fully closed quickly, so they are particularly useful for the emergency shutoff of valves. A solenoid actuator consists of a wire coil, spring, armature, and stem, which is connected to the valve. When current flows through the wire coil, it creates a magnetic field around the coil. As a result, the coil becomes an electromagnet. The armature, which is a solid metal core, is attracted to the magnetic field, so it is pulled toward the center of the coil. As the armature moves, it compresses the spring and moves the stem, which opens the valve. When current flow through the coil stops, the magnetic field is lost. This allows the spring to push the armature and stem back to their original positions, closing the valve. There are no intermediate positions with a solenoid actuator. They are either fully open or fully closed, so they are only used for on-off valves, not throttling valves. Also, solenoid actuators do not produce a great deal of force when they operate, so a different type of actuator is generally used when more force is needed to position a valve. When a valve has to be throttled, or when a large amount of force is needed to position a valve, a motor-operated actuator, or motor operator, may be used. A motor operator consists of a motor and a set of gears that turn a valve stem to open or close the valve. A motor operator also has a hand wheel, a lever, a limit switch, and a torque switch. When the motor operator is energized, the motor drives the gears. The gears move the valve stem to position the valve. The lever is used with the hand wheel to position the valve manually if there is a problem with the motor operator. Depressing the lever disengages the motor from the gearing and connects the hand wheel to the valve stem through part of the gearing. The limit and torque switches ensure that the valve is positioned without damaging the valve or the motor operator. The torque switch cuts off the current to the motor when the torque, or rotational force, produced by the motor operator reaches a preset value. Ideally, the torque switch limits the force on the valve stem to prevent damage, while at the same time ensuring a tight seal between the valve disc and seat. If an obstruction blocks stem movement in a valve, a properly set torque switch can cut off the motor before damage occurs. The limit switch cuts off current to the motor when a valve reaches a preset position, keeping the valve within the desired range. For example, the limit switch shuts off the motor when the valve is fully open.